Hi, I thought I would post a couple of short videos about how to get started using a PicoScope. These videos are going to be mostly for my GCSE electronics students, maybe a couple of my A-level students as well. And if you're not one of my students but you find the videos useful, please do subscribe and add a comment. And if you think that these videos are good or you'd like to see something that's slightly different, then just let me know via a comment. Okay, so let's get started. The circuit is a monostable timer. So if I press this switch, you'll see this LED lights up just briefly. Okay, this LED here is just showing me when I've got my power on or off. Okay, and we're going to use the PicoScope to just make a few basic measurements. So I've already connected the scope probe up to channel 8. For the start, we're only going to use one channel. It's a dual channel scope. Don't connect the probes up to the output. This is the waveform generator, arbitrary waveform generator. We're not using that at the moment. And so the other end of the scope leads is this. So this, I'm doing this video at home. So and this is my scope, my probes, and I can write over them. So channel A, I find that convenient. This is the ground clip. And normally speaking, that's going to be connected to 0 volts. There are exceptions to that, and there's a whole load of safety issues about that, which I'm not going to cover in this video. But we can take voltage measurements with this. Now, because I need to clip this on somewhere, the easiest, I mean, you could, if you wanted, just clip onto, say, the leg of a component. I generally think it's easier, most students probably find it easier to just put yourself a little jumper wire in and then clip onto that wire. Okay, so that's what I'm going to do there. The probe tip ends, well, it's retractable, so you can put it like that, you can clip on. But if we're just going to probe around the circuit, just to get started, let's just pull that off, and you'll see there's a nice sharp point. Okay. Now, at the moment in the software, let me just resize this because we're going to be looking mostly at PicoScope software now, I think. So you'll notice hopefully that we've enabled channel A, and that's on an automatic voltage scale. So we could, if we wanted, select a voltage scale. We will do that in a while. Channel B is off. Okay. So we can use this like as a voltmeter, and I can just probe. So let's just probe here, and you'll see that that reading now is something around, well, it's somewhere between 3 and 4 volts, probably about 3.4 volts or something like that. Okay, so you can probe elsewhere in the circuit. For example, I could, well, here's my supply from my battery, and so the bottom is 0 volts. Let's just confirm that 0 volts. So yeah, it stays at 0. Notice, by the way, at the moment it has rescaled itself, so now we're in the millivolts range, and so all of this stuff going on here, that's just noise. Okay, so if I probe to the anode of this protection diode here, you'll see that we're now just above 4 volts, and then of course when we go to the other side of the diode, we would expect a drop of something like about 0.7 volts. So as you can see, we can probe our way around the circuit. You can, with a degree of care, that, as I say, there are lots of issues about doing this, particularly when anything is connected to mains, either directly or indirectly, about moving that probe, the ground clip, to other parts of the circuit other than 0 volts. But I can, in this particular circuit, go across the diode now. So I'm just going to measure the voltage drop across the diode, and then you'll see, and in fact we've got a reverse voltage there because of the way that I've put the ground clip and the probe tip, but that doesn't make any difference, and it's just like a digital multimeter. If you put the leads around the wrong way, it's just going to give you a negative measurement. Okay, so we've probably got something like about 0.7 volts there, which is what I would expect. Let's just take that out for the moment. And so up till now, what we've done, we've just allowed it to auto range, and probably you'll notice that if you listen carefully, I'll give you a chance to listen. Hopefully you heard that there are relays that are inside this, and they're clicking in and out, and that's happening when it's changing the ranges. Now, actually having changer scales is not particularly useful for us. I'm not interested in millivolts ranges at the moment, so I'm just going to click this, And so let's go to say 5 volts. So now we go up to maximum of 5 volts and down to a minimum of -5. And even though I'm no longer touching any part of the circuit, it stays in that voltage range. So now when I probe the supply, it's, well, once again, it was like something like it was before, 3.4 or something volts. Right, now it'd be nice if we can take some more useful measurements rather than just reading on that scale. So let's go on to measurements, add measurements, and then you can select which channel. Now at the moment we're only using one channel, channel A, but we can then choose what we're going to measure. Let's say the DC average across the whole of the trace, that's from left to right. And we click on OK, and at the moment you'll see that it's running all around the place at the moment. So let's now probe the supply rail, and it's roughly, it's about well, it's nearly 3.5 volts. Hopefully you can see that. Let me just point that out down there. So I'm looking down there now. By default, the font that the PicoScope software uses is not, well, I don't like it. Or rather, the font size. If you go to measurements, you can actually change that. I think it starts off with something tiny to start with. And but you just go on to measurements, grid font size, and you just change it to whatever you feel comfortable with. If you change it to something massive, oops, sorry, wrong thing there. If you change it to something massive, then I think, let's try that again. If you change it to something really big, oh, actually, it's showing just fine. I think I've found in the past that sometimes you get like the values truncated, but that's actually quite nice and clear. Right, so we'll leave it on that one for the moment. So now what I can do is I could probe different parts of the circuit. Now it's a monostable timer, so pin is going to be triggered when pin 2, which is the trigger pin, goes to low. So normally it's going to be pulled high. So if I just probe pin 2 on the 555 timer, you'll see that we're on logic high of something about nearly 3.5 volts. So when I press that switch, briefly, as long as I've got my finger pressed on the switch, it's taken it to a logic low of 0 volts. It would be nice to see that voltage change over time along the trace. So what we can do here, we can now start playing with this. Now, how long am I going to have my finger on the switch? Well, not too sure at the moment. So let's do a fairly slow time base. So let's say, well, 500 milliseconds per division. And now you see it slowly going across the trace, or a trace slowly going across the screen, maybe. And then let's probe pin 2. And now you'll see that, in fact, if I take my probe tip off there and then probe again, okay, so you can see that it's responding to that. So now when I press the switch, it goes low. And then when I release the switch, it goes high. And if I mess around like that, it goes like that. Okay. Now, what would be quite nice would also be to measure the duration of a switch press, and we're going to be doing that in a while, and also the duration that the LED is illuminated for, bearing in mind it's a monostable timer. So let's just probe the output pin, which is pin 3, and so that's the output. Let's just wait for the trace to develop there, and I just pressed and released. And so what would you say that is? It's a bit difficult to say for sure, isn't it, exactly what that time duration is. You could have a go, but unfortunately in the while that you're actually trying to read the scale across on the bottom, it's problematic. Okay, so what would be nice would be to actually have some sort of way to freeze that trace on the screen. You can certainly do that, and to do that we have this thing down the bottom which is called triggering, which has nothing to do with the trigger on the 555 timer. So I'm only interested in one event, so I'll have a single event trigger, and I will have it triggered when the voltage rises. We call that a rising edge trigger. Okay. Notice now we've got this little thing here, and what I'm going to do, you can just drag this around the screen, and so I'm going to put it on the left hand side because, well, you're going to see that the trace is going to go up, and then it's going to go along, and it's going to stay high until I release, and then, oh sorry, not release, because I'm not doing the switch, we're doing the LED. When the LED then goes off, it's then going to fall back down. So I want to leave some room for it to be high and then to fall back down. Now all that this thing is doing, I can change the height of this by dragging it around. It's also changing this hit thing here. So let's say if I drag that up to approximately 2 volts, you see that's 2 volts, then it's saying, yeah, it's more or less 2 volts, isn't it? Down there, 1.984. So, so when the voltage rises to 2 volts, then the triggering is going to happen, and then the screen's going to be frozen. You're going to get to see what I mean in just a moment. Okay, so let's just probe pin 3, the output of the 555 timer, and I'm going to press that switch briefly. And then when it gets to the other end of the screen, that's it. Now I can remove the probe. It's no longer needed to be on there because that was triggered and it was captured. Okay. So now it would be nice to know what that duration was. So I can go on to measurements. I can add another measurement, and then this time still channel A. The type of measurement is going to be, well, what do I want to have? I want to have the high pulse width. That seems about right across the whole of the trace. Click on OK, and now that tells me that the LED, or the pin 3, which is then lighting up the LED, is 259. Sorry, not 259. I'm reading the wrong thing there. High pulse width is 638 milliseconds. Okay. Now I think that's probably, I can't quite remember whether I pressed the switch briefly. I think that might be longer than the time is actually set to, because I might have had my finger on the switch. So let's just try that again. Okay. Can't remember what timing I set up on this monostable. So we just click run again, and I then I'm going to probe pin 3, the output, and this time I'm going to be really brief, like that. Okay. And then I can take the probe off there. And actually the timer is indeed set to be about 637 milliseconds. Okay, so that's the high pulse width. If you want, you can, let's just get rid of that trigger. Let's just say no trigger for the moment. Let's just click run. Okay, so now back to normal. What we could do, we might want to see like how long a switch press is for. Okay. So the switch, before it's pressed, is going to be a logic high. So in this case, what we want to do, we want to have triggering when it falls to a logic low. So let's do that. So what we're going to do then is we're going to say we'll have a single event trigger, and it's going to be when it's falling. And so what's it going to need to fall to? So you could say, for example, that when it's fallen to, say, below 3 volts, then it's going to then trigger, which will be fine. But I mean, we know that when we press the switch, it's actually going to fall down to close to 0 volts anyway. So you could equally well have that trigger level threshold set down there. It doesn't really matter. Okay, so let's do this then. So I'm just now going to press the switch, and there we go. Okay, and so that was a nice brief press there. And so what was the duration? Well, at the moment the high pulse width measurement is meaningless. That's of no use to us, so I'm just going to add another measurement. By the way, we went into measurements there before, but we could just as well go down to here and add a measurement there. So let's do that this time. And then you could say the low pulse width, and click on OK, and then you see that the low pulse width was 88 milliseconds. So, by the way, if you don't want those things, you can easily get rid of them. You can just subtract them like that. I think you can also possibly just right click on them. Yeah, you can. Okay. Other things, if you're one of my students, that you might want to do, you might want to then think that you're going to change the time base, because at the moment 500 milliseconds per division may be a little bit long, so maybe we go for less than half of that. So let's do that. Let's now run. And so now we're currently, well, we haven't got triggering at the moment, so let's now probe the output of the switch. In fact, let's probe over here. Sometimes I knock that switch out. Okay, so and then let's see what we've got. So we're going to have single trigger. We're going to have it on a falling edge. Yeah, that'd be fine. That's what we want. Let's start running. And then, when I then press the switch, as brief as I can, like so, and then, so what have I got? I've got 64 milliseconds. And I think when I tried this before, it's rare that I get under about 40 milliseconds or something you can try yourself. And of course, if you want to, you can always further reduce the time base. And when you start reducing the time base even more, then you start to see that there's a little bit of bouncing on the switches, invariably, a little bit of bouncing on the switches as well. So hopefully that's covered a few things that are of use to my students or anyone else who might be watching the video. Don't forget that if you're going to use an oscilloscope, you're not one of my students, do check out, there's got to be some safety information out there. Probably go onto the PicoScope, the actual manufacturer's website. I would think that there's going to be some good stuff there. Also, there's a good YouTube channel called EV Blog, and there's quite a comprehensive video about safety, and I would suggest that you watch that one too. Okay, that's it for now for this video, and if you found it useful, please do subscribe and give it a thumbs up. Thanks.